Chapter 3, Lesson 3, Rate of Change and Slope. So when we talk about the rate of change is just a ratio that describes, on average, how much one quantity changes with respect to a change in another quantity. So we're just comparing how things change with each other. So when we think about like in a table, we talk about the change in y over the change in x, and that's talking about our rate of change. Change sounds a lot like what we talk about when we talk about slope. So when we talk about rate of change, it can vary, right? It can go up and down, right? Think about like the stock market. It might go up one day, then down another, then up the next day, then up the next day, but up a little bit less the next day, and then down a lot the next day. And so the rate of change can vary. It doesn't always have to be the same, whereas the slope is always it remains constant. And slope is like what we think of in a line. A rate of change might be going up and down and up and down and up and down. And it doesn't have that constant change, and so it doesn't create just a straight line. Okay? Linear functions are always going to have a constant rate of change. And that's also known as the slope, which is what we usually talk about it as. So if I need to look at these and decide if they are linears, what I'm going to do is I'm going to decide, do they have a constant rate of change? So let's look. So from here to here, we're going to find the rate of change. Well, the rate of change said find the change in the y's over the change in the x's. So the change in the y went from -6 to -8. So it went down 2, so -2, over, and the change in x went from 1 to 4. It went up 3. So my rate of change is -2/3. And then I look from here to here. Well, I went from -8 to -2, so I went down 2, and I went from 4 to 7, up 3. My rate of change is still -2/3. Here, I went from -10 to -12, so down 2 and up 3, so still -2/3, and we got to check the last one. From -12 to -14 is down 2, and 10 to 13 is up 3, so -2/3. So yes, this is linear. So not only does it have a rate of change, it has a constant rate of change, which is that slope. So let's look at this one. All right, my change in y, I went from 10 to 12, so I went up 2, and I went from -3 to -1, which is also up 2, so my rate of change was 1. From here to here, I went from 12 to 16, I went up 4, and from -1 to 1, I went up 2, so my rate of change is 2. As soon as I get a different rate of change, I can say, no, it is not linear. I don't have to check anymore. Okay, so when I talk about the slope, we have a lot of different ways that we refer to the slope. Okay, but the slope is basically just the ratio of the change in y to the change in x. Okay, so we talk about a lot of different ways. The most common way that we talk about slope is rise over run. We can also say it's a ratio, so it's the change in y over the change in x. All right, and we talk about the slope as any of those ways. Our slope formula that we use is y2 minus y1 over x2 minus x1. And so when I have two coordinates, I have x, y, and x, y. Those little 1s and 2s are just describing like basically the first coordinate and the second coordinate, just so we can keep them together. And as what we have to remember is that if we put the y from the second coordinate first on the top, we have to put the x from that same coordinate first on the bottom. Okay? So when I talk about slope, slope can either be negative, it can be positive, it can be undefined, and it can can have no slope, or sometimes we also call that a zero slope. Okay? A negative slope is going to be in this direction. It's going to be going up and to the left. A positive slope is going to be going up and to the right. An undefined slope is a vertical line, and no slope is a horizontal line. We'll talk a little bit more about those in a minute. So an undefined slope, we just said it's a vertical line. It's an undefined slope because it is steep, but it's like so steep that we can't even put a number to it. And when I use my slope formula and I have a fraction, when I do that y2 minus y1 over x2 minus x1, and is what's going to happen is that, remember, this is the rise and this is the run. Well, in this case, there is a rise. There's a lot of rise. So there's actually going to be a number here, and my run is going to be 0. So if I get that, it tells me it's an undefined slope. No slope is a horizontal line, and what it is that when I get that fraction, there is no rise, but there is going to be a number here for the run. So if I get a 0 in the denominator, it's undefined. If I get a 0 in the numerator, it's no slope. Let's do an example. So if I have the points -2, 0, and 1, 5, and I want to find the slope, so I'm going to label them. This is x1, this is x2, this is y1, this is y2. So I'm going to use that slope formula, y2 minus y1 over x2 minus x1. So I'm going to put 5 minus 0 over 1 minus -2. So I'm going to have 5 over, zoom, zoom, 3. And my slope of this line is 5/3. I'm always going to simplify, but I'm never going to change it into a mixed number.